In this video, we're looking at section 1.2. We're going to solve multi-step equations. Okay, so our learning targets for today. We will be able to solve multi-step linear equations using inverse operations. At the end of this video, we will also be able to use multi-step linear equations to solve real-life problems. Our core concept that we're looking at today in solving multi-step equations is to simplify each side of the equation, if necessary, and then we're going to use inverse operations to isolate our variable. Alright, so on to example 1. We're solving a two-step equation. That means it will take us 2 steps to solve this equation. So remember, when we're equation solving, we have an overarching goal. And our goal when we're equation solving, our goal is to isolate the variable. Okay, so we've got to get that variable by itself. So here's our equation. 15 is equal to 1.5 times r plus 3. So in order to get the r, which is our variable, by itself, we need to do inverse operations to isolate the r. So we're going to go in reversed PEMDAS order. Remember, parentheses, exponents, multiply, divide, add, subtract. So we're going to go in this order when we're undoing an equation using inverse operations. So if anything is added or subtracted to the variable, we're going to do that first. So since 1.5r has 3 added to it, we're going to subtract 3 on both sides. And we're going to have 12 on the left-hand side is equal to 1.5r. Remember, positive 3 and negative 3 add to 0, so we're just left with 0. 1.5 is multiplied to r, so the opposite of multiplication is division. So the inverse operation to multiplication is division. We divide both sides by 1.5. Take a minute and go ahead and divide 12 by 1.5. And hopefully you had 8. Next example, we're looking at a multi-step equation where we're solving it by combining like terms to solve the equation. So here's our equation. 5f plus 4f minus 8 equals 19. So the first step we want to do is combine our like terms. And remember, like terms have the same variable raised to the same power, or the same exponent. So in this case, we have f and f here, and the coefficient on this f is a 5 and this is a 4. So we're going to add these two terms together because they're like terms. So when we add our coefficients, 5f plus 4f, we end up with a 9f. And then we're subtracting 8, and then this is equal to 19. All right, continuing to solve, remember we're using that reverse PEMDAS order. So we're going to add the 8 as our next step. Again, make sure you show every single step on your homework. 9f is equal to, so 19 plus 8 is 27. We're dividing both sides by 9 because 9 multiplied to f, the opposite of multiplication, is division. 9 divided by 9 simplifies to 1, so we get 1f is equal to 3. All right, so our next example that we're looking at is a multi-step equation where we have 4 times the quantity of n minus 6 minus 1 equals 31. So there's a couple of ways you could do this problem, but if we did the reverse PEMDAS order, then we would start with the addition and subtraction. So we can see that on the left side, in order to get the n by itself, we have this quantity that is subtracting 1. So opposite of subtraction, we should add 1 on both sides. And when we do that, we end up with 4 times the quantity of n minus 6 is equal to 32. Continuing up on the reverse order of PEMDAS, we're looking for anything that's multiplied or divided to the variable. So we see that 4 is multiplied to this whole quantity here. So the opposite of multiplication is division. So we're going to divide both sides by 4. 4 divided by 4 gives us 1, so we're left with n minus 6 is equal to 8. And now the parentheses are really not necessary, and we're left with n minus 6 equals 8. So to isolate the variable, we're going to do the opposite of subtraction, which is addition, and we're adding 6 on both sides. And when we do that, we see that n is equal to 14. All right, our last example in this video, we are modeling with mathematics. So we're applying our equation solving skills to a real life problem. And here's our problem. We're going to use the table to find the high temperature X on Wednesday. So here's our variable. So that the mean high temperature for the 5 days is 65 degrees Fahrenheit. So I encourage you to pause the video and see if you can develop an equation based on the 5 temperatures, 4 that are given, 1 that's a variable, and the idea that the mean or the average high temperature for 5 days is 65 degrees Fahrenheit. Okay, and let's see how you did. So if we know that the mean is 65 degrees Fahrenheit, in order to find the mean, or the average, we're going to take all of our values and add them up and divide by the number of values. So there's 5 days, so we have Monday's temperature of 76 degrees, plus Tuesday's 70 degrees, plus Wednesday, which we don't know, that's our unknown, plus Thursday, which is 68 degrees, plus 55 degrees on Friday. And if we're finding the average, we're dividing this by the number of days. So there's 5 days, and this is equal to 65 degrees. So since we're solving for x, in order to isolate the x, the first thing we should do is multiply both sides by 5. Since all of these values are added together and then we're dividing by 5, the opposite of division, multiplication. So we're going to take both sides and multiply them by 5. So 5 in the numerator and 5 in the denominator is 1, and we're left with 76 plus 70 plus x plus 68 plus 55 is equal to 325. All right, next we're going to add all of our constant values. So all of these constant terms, we're adding them up. And when we do that, we have x plus 269 is equal to 325. And so since we're adding, we're going to do the opposite operation in order to bring the 269 to the other side. So we're going to subtract 269 on both sides. And when we do that, positive and negative 269 is 0, and we're left with x equals 56. Now we want to make sure that we label this. Remember, we're looking at temperatures for a week, so this represents the temperature on Wednesday. So this is 56 degrees Fahrenheit as our answer, and we are boxing it.